Assalamualaikum and good day. Welcome to Analog Electronics 2 class. Today, I would like to start the lecture with a new topic in Chapter 1, which is the Introduction to Field Effect Transistor. Before we go into detail about the field effect transistor, okay, I will show you the overall of the review for the whole topics in this chapter. What we will learn from this chapter is FET types, where FET types we have 3 types: JFET, DMOSFET, and eMOSFET will be covered in this topic. And then for each type, we go into detail for the basic construction. Basic construction will explain about the materials, shapes, channel, and terminals. And next, we will go to the FET operation, which is you will know how FET works, and you also know when FET will be on and will be off. This operation will be explained by visually. I already make some animation for this topic, and then we will go into detail for the FET characteristic. In the characteristic, you will get the graph, the parameters, and also we will discuss about the data sheet. And then after that, we go to the mathematical equation that we get from the characteristic. Okay, the mathematical equation that used for each FET type. And then actually what you learn from this topic, you will use in chapter 2, chapter 3, chapter 4, and chapter 5 and chapter 6. So I want to conclude that this is very important part that you must know in chapter 1, that you will use the knowledge in another chapter. So the rest is the FET application, which is amplifier circuit. Let's go to introduction. FET are more temperature stable than the BJT. FET are smaller than BJT, making them suitable for the IC chip. These two are advantages of the FET compared to the BJT. All FET will have N2 type of channel, which are N channel, which is the most commonly used, and also the P channel. There are 2 types of FET will be introduced in the chapter. The first one is junction field effect transistor. We call it JFET. And the second one is metal oxide semiconductor field effect transistor, MOSFET. Field effect means that an electric field is established by the charges present, which control the condition part of the output circuit without the need to direct contact between the controlling and control quantities. You will understand the meaning of the electric field and the meaning of the control the conduction part in the next part, where I will explain in detail how the FET, especially the VGS, will control the conduction part. Then the FET is a voltage control device, while the BJT is a current control device. You must able to differentiate what is the difference between the BJT and the FET. In Analog Electronic 1, you learned about the BJT, where BJT is the current control device, where the IB actually control the output of the IC. And now for the whole chapter, for the FET, the control here is VGS. Okay, the difference is FET for the voltage control device and BJT is a current control device. I want to show you an analogy of a FET to give you the overview how the FET work. The working mechanism of FET can be analogized as in figure below. Okay, FET has three terminals, three legs here. First is D, call it drain, G for gate, S for source. So there is a VGS in between the G and S terminal. Okay, let me see the analogy of the water tap. If you see, let's say the water tap from the top is the source. The water come out from the source and go to the drain, where here the water tap is controlled by pulling this one, the gate, and then you see that when we close this gate, so the water cannot flow from this tap. When we open, and the water will flow. Okay, so this analogy from we can see that the water flow from the source to the drain. So same goes to the analogy, but the direction is the drain is at the top and the S is at the bottom, but the analogy is same. Like for the FET, this analogy is for the electron, where the electron come out from the source and go to the drain. So in FET, we can say that the electron will come out from the S and go to the D, to the drain. This analogy are same. However, you will see the configuration of the FET for the D terminal is on top and source at the bottom. So the current actually will flow from D to S. Okay, it has opposite direction from the electron.